Welcome back, Geometry Video 2 here, focused on altitudes. So let's have some fun with altitudes, right? So the concurrency of altitudes idea here. So again, if we look here, altitudes are perpendicular, right? So they will be concurrent. So if you graph the three altitudes, they will all meet at the same point. So the next slide talks about, sorry. I saw the decimal geometry down here. So this point is called the Orthocenter. It'll be on the next slide as well. The Orthocenter. So let's use Desmos geometry and let's go ahead and construct this Orthocenter. Okay. All right. So again, let's just draw whatever kind of triangle. I'll try to start acute first. There we go. Okay, so we need to draw two altitudes, right? So I'm going to draw, let's see, construct perpendicular. I'm going to go from the top. Oh, I'm sorry. You have to choose the slope first. So I apologize. So perpendicular. So choose the line you want to be perpendicular to. I choose this one, and then choose the opposite vertex. There. And that angle right there, if you want me to measure it real fast, that's your right angle. There you go. Do the same thing here. Let's choose this side and this opposite vertex. And again, if you want to measure the angle to show you that it's a right angle, there you go. The point where they cross right there, that is going to be called the orthocenter. Again, remember, you only have to do two of the three segments. So we only did two altitudes. If I did the third altitude, it would also go through there. So you can notice here that when you make this triangle acute, the orthocenter is in the inside. Now, what happens if I make this angle a right angle? So let's see what happens. Notice, look what's happening. As I get closer to the right angle, boom, the orthocenter goes at the right angle. So that is a huge idea. If you have a right triangle, the orthocenter is at the right angle. And it should make sense to you because in a right triangle, because this is a right angle, the two sides here are actually the altitudes, right? So from this vertex right here in the right corner to the opposite side right here, that leg is the altitude. And same thing up here, okay? And now as I make that angle become more obtuse, notice where your orthocenter goes. It's going outside of the picture. Notice here that the right angle has disappeared, right? It was right there, now it's gone. That's because this altitude is now outside of the triangle. If I extend, let's see if this happens. If I extend this, right, so now this angle right here would be a right angle. And as I move this angle back, you can notice that there I have both of those right angles, right? So there you go. Okay, so that's how you construct the altitude, or the orthocenter with altitudes. All right, so let's take a look at this next slide here and see what we're going to talk about. Sorry. Okay, so this mentions the orthocenter, right? The orthocenter is the point of concurrency of the altitudes. Yes, we just talked about that. And again, we talked about where it's going to be depending on what kind of triangle it is, right? So here's that summary. So the orthocenter is outside an obtuse triangle and inside an acute triangle. For a right triangle, the orthocenter is at the vertex of the right angle. So very, 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 very important idea here to remember. And again, I used Desmos geometry already to show you what the orthocenter would be. Okay, so now, if you're an algebra fan, if you're an algebra fan, get ready, because here comes some serious algebra. We are going to locate the orthocenter for this triangle. Okay, what this is going to require, okay, and we're going to use coordinate geometry, is a system of equations. We have to solve this using a system. So we need to find the equation of two altitudes in this picture. All right. Now, the first one I'm going to choose to use, right, goes through K. So if you're lucky enough to have a point 0, 0 as one of your one of your corners of your triangle, please, please, please use that, right? So what we're going to do here is we're going to create equations for two altitudes. So that's step one, right? Step one, find equations for two altitudes. Okay, so first and foremost, let's take a look at where K is. The opposite side would be ML, right? So to do this, we need to use ML and find its slope. So that's what we're going to do. We're going to find the slope of segment LM. So we're going to go down 1, 2, 3, 4, 5, 6, 7, right 1, 2, 3, 4, 5, 6, 7. Right, let me do that again. Down 1, 2, 3, 4, 5, 6, 7, right 1, 2, 3, 4, 5, 6, 7. So that's a slope of -7 over +7, and that's just a slope of -1. We will need the opposite reciprocal of that slope. So the slope we need for the altitude is going to be a +1. Okay? So now if you want to, you can draw this. If you go from K, go up 1, right 1, 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 right? This is going to be the altitude we're going to find the equation of. And that should be a perpendicular. All right, so let's find that equation. So I'm going to use point slope form. So the point I know is 0, 0. And the slope is 1, right? So actually, yeah, that's fine. So point slope form. So y minus y1 equals m times x minus x1. The zeros both cancel, and it just becomes y equals 1x, right? Y equals 1x or x. This is our first equation. Okay, so that was pretty easy. So if you're lucky enough to have that, that's great. Okay, now I'll do the second one. Second one's a crapshoot. Doesn't matter which one you pick, you can choose. I think it doesn't really matter. I don't know. I'm trying to think. Let's figure out some slopes here. So what's the slope of KL real fast? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have up 5, right 10. That'll be a 1/2 slope. What's the slope of KM? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. So that's going to be a slope of up 12, right 3, which would be a slope of 4. But remember, we have to use the opposite reciprocal. So I'm actually going to use the slope of KL because when you take the reciprocal of 1/2, it's going to be a whole number. Okay? Which means I'm going to draw my median from M, or my altitude from N, M through KL. So let's find the slope of KL next. So K to L, we kind of already did it. It's up 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 5, right 10. That simplifies to 1/2. Again, because these are altitudes, I need the opposite reciprocal. So the slope of this altitude is going to be -2. And from N, you can count. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. And there we go. Now, I have my Orthocenter. It's right here. It looks like the Orthocenter could be at the point 6, 6. But I want to verify using algebra. Okay, I do. Okay, so let's create this equation. So the point I have is M at 312. And I have a slope of -2. Slope equals -2. So we're going to use point slope form. Y minus y1 equals m times x minus x1. Y minus 12 equals -2x plus 6. Distribute that. -2. And then we're going to add 12 to both sides. And I get y equals -2x plus 18. So there's the two equations I need. Okay. And now I'm going to erase some of this stuff so we can do part 2. All right, so give me a second back, eraser. Let me erase. I'm going to pause it so I can erase quickly. Okay, so now step 2 is where you're going to solve the system. So step 2, we're going to solve the system. So my two equations were y equals x and y equals negative 2x plus 18. So notice that both of these are solved for y. So what we're going to do is essentially we're going to get rid of the y's and set the two expressions involving x equal. What we're really doing is we're taking this x and plugging it in for this y in the bottom equation because y equals x. So this now says x equals negative 2x plus 18. And I'm going to solve this for x by adding 2x to both sides. 3x equals 18 and dividing by 3. And I get an x value of 6. So now to find the y, because I need the ordered pair, I'm going to take this x and plug it into one of the equations. Well, no duh, plug it in the first one, right? Y equals x, so y equals 6. And there we go. The x is 6, the y is 6, and that verified the orthocenter was at 6, 6. Okay? Now, this problem can be difficult if you don't have a k value where it goes through 0, 0, right? If you have to use like m and l, it can be a little bit more cumbersome to solve. So yeah. So there we go. Cool. All right. So I hope these videos were fun for you, and we'll see you in class.